Subject Nuclear Physics, course for the BSc. Chapter number 1. Name of the chapter is General Properties of the Nucleus, and topic is Angular Momentum of the Nucleus. This is sixth part of this video lecture series, which is made for the BSc Nuclear Physics. If you are interested, you can like my Facebook page at www.facebook.com/Apni Physics, and these video lectures you can visit anytime at my blog www.apniphysics.com. I will discuss about that how one can determine the angular momentum of the nucleus. If you have the idea of angular momentum from the atomic physics, you can understand it better in the same way. So as you know that a nucleus is made of by protons and neutrons. So here they symbolize protons and neutrons with the color. As you know that neutrons and protons are fermions, so they have intrinsic spin angular momentum 1/2 in unit of h cross, right? So in general we write intrinsic spin angular momentum of the proton and neutron h cross by 2. There is a small concept of the center of mass. There are two masses A and B. The mass of this object A is m1 and mass of the object B is m2. We have defined here that m1 is greater than m2. Simply you can take this example. If suppose m1 is equal to 1 kg and m2 is only 1 milligram, that is very small. So there are 5 options: 1, 2, 3, 4 and 5. Center of mass will be towards the heavy object or towards the lighter object, or it will be at the center of these two objects. Where will be the center of mass? So there are 5 options: A, B, C, D, E, right? So let me know where will be the center of the mass for this particular system. So here A is heavier as compared to the B, so center of mass will be towards the heavier object. The answer of this is A. I am not going into the mathematical formulation, but conceptually center of mass will be towards the heavier object. The nucleons possesses quantized orbital angular momenta about the center of mass of the nucleus. Angular momentum of the nucleus is represented by capital I. Orbital angular momentum of the nucleus is represented by the capital L, and spin angular momentum of the nucleus is represented by capital S. So nuclear spin angular momentum of the nucleus is vector sum of the orbital angular momentum and spin angular momentum. This is very simple definition, and further we will see that if a nucleus have large number of nucleons, so then that time how one can define the nuclear spin. The resultant spin angular momentum of the nucleus is obtained by vector addition of the spins of the individual nucleons. So capital S is equal to summation over I SI, where I represent to the nucleons: 1 nucleon, 2, 3, 4, 5 and so on. So if you want to find out the total spin angular momentum, then you have to add all the absolute values of the spin angular momentum. Since you know that spin angular momentum is equal to 1 by 2, so S1 will be equal to 1 by 2, S2 will be equal to 1 by 2. When you will add these two, so S1 plus S2 is equal to 1. If there are 3 particles, 3 nucleons, then that time total S will be sum of these 3, S1, S2 and S3, and now the spin angular momentum is 3 by 2. If there are 4, then it will be 2, and similarly you can add. So this is the result of spin angular momentum. Similarly, the resultant orbital angular momentum is given by capital L, that is summation over I to Li, right? So L represent the orbital angular momentum of one nucleon, L1, L2, L3, L4 and so on. So by this way one can calculate the nuclear spin, right? So now the nature of spin S, it will be integral or half integral. It depends on the number of nucleons in the nucleus. If number of nucleons, total number of nucleons in the nucleus are even, then total spin angular momentum will be integral. As you have seen here, there are 2 nucleons, this is 1. There are 4 nucleons, this is 2. And similarly for the 6 nucleons, there will be 3. So integral nature of spin angular momentum is integral if number of nucleons are even. If number of nucleons are odd, 1, 3, 5, 7, 19, 21 like this, then S will be half integral. So here I is nuclear spin and this is equal to 0 only when Z and N are even numbers, right? So nuclear spin is equal to 0 when N and Z are even number. Which nucleons determine the value of spin? We have seen recently that the nuclear spin is the sum of vector L and vector S, and we had find out the value of capital L and capital S, keeping in mind contribution of all the nucleons. But now the question is that which nucleons determine the value of spin of the nucleus. Second question of discussion is, what is the concept of core into the nucleus? What is the spin of core? That is of the core. What is the core into the nucleus? And does core have any nuclear spin? So this is the second question. First question is that which nucleons determine the value of spin. So now majority of the nucleons forms a core, and in this core even number of protons and neutrons are grouped in pairs of 0 spin and orbital angular momenta. So L is equal to 0, S is equal to 0, as a result I is equal to 0. So this I is equal to 0 for the core. So in a nucleus even number of protons and neutrons are grouped in the form of pair, and as a result they provide L is equal to 0 and S is equal to 0. Now rest of the nucleons outside that core determine the value of the nuclear spin. For an example, if suppose this is the central part of the nucleus is in the form of core. So this is the core, and there are even number N and Z nucleons. Now rest of the nucleons are these, right? These are not into the core. So the nuclear spin is determined by the nucleons which are outside the core. Now we will analyze this concept. First of all, we have seen that these statements are saying that nuclear spin is some vector sum of the orbital angular momentum and spin angular momentum of all the nucleons. Nuclear spin is defined by the vector sum of the orbital angular momentum, total orbital angular momentum of all the nucleons, and total spin angular momentum of the nucleons, of all the nucleons. And the way of determining the total orbital angular momentum is equal to the summation over I orbital angular momentum. L1 or L2 represent the orbital angular momentum of one nucleon for the second nucleon, and similarly for the third nucleon. Similarly, one can determine the value of total spin angular momentum by adding the spin angular momentum of all the nucleons. So by taking a simple example of the uranium-235, where proton number are 92 and neutron number are 143, the ground state spin should be equal to the vector sum of L and S. Total spin will be equal to the sum of these two. Experimentally measured, the highest value of nuclear spin is 9/2. It means there are only 9 nucleons are contributing into the nuclear spin. S1 is equal to 1/2, S2 is also 1/2, S3 is equal to 1/2. If you add all these, you will get the value of total S. S1 plus S2 plus S3 and so on. So by this way you can find out the capital S. So here N is equal to 143 and Z is equal to 92. So in case of neutron number, these are 143, and for each nucleon the value of spin angular momentum is 1/2. So when you will add the value of for 143 nucleons, it will be 143/2. And similarly for all the protons, the value will be equal to 92/2, but experimentally, as you know, that is 9/2. It means, and this is the highest value measured experimentally for the nucleus. So here 9/2 is very small as compared to the 143/2, and similarly for the 92/2. So in every case this value, experimental measured value, is small as compared to the concept which is explained to determine the value of nuclear spin. So here it means, so I is equal to L plus S concept is wrong. If this fact is true and the value of only S is greater than the value which is measured experimentally, does this concept for the nucleus to determine the value of nuclear spin I is equal to L plus S is wrong? No, this is not wrong. Actually what happens, maximum value of the nuclear spin is 9/2. It means that there is only 9 nucleons which are contributing to the nuclear spin, as I told. What happens actually, even number of N and even Z form a core, right? And these even number of N and Z nucleons grouped in the pairs, and because of that S is equal to 0 and L is equal to 0. Total spin angular momentum of the core becomes 0. I is equal to L plus S. Now rest of the nucleons which are outside the core, they determine the value of I. So if in case of uranium, so now the question is how to decide number of remaining nucleons outside the core which determine the value of nuclear spin. That is basically cell model which help us to determine the number of nucleons outside the core. What is the cell model and its explanation we will see into the coming lectures. So this was just a simple analysis of the angular momentum of the nucleus. Thanks for watching this video. Please like and subscribe if it was helpful.